Hey math lovers and haters, as per a video request I have received, I will quickly go over matrices today with how to understand where they come from and how to use operations on them. While my points on matrices might not line up with the background math, it will still be good to look at the background to absorb the topic more thoroughly. Matrices are mainly a way to more easily write linear functions in an easy to digest format. So, a linear function is a function with multiple single order variables with number coefficients. To put it more simply, instead of the typical y equals mx plus b learned in American schools, a linear function can have multiple different variables on the right side of the equals. For example, 2x plus 3y plus z equals 0 is a linear equation. Now, these linear equations can have single solutions only if, for every variable, there is an equation for that variable. Well, if you represent linear equations by only their coefficients, and then put the coefficients row by row, that's your matrix. Matrices have peculiar properties because of this fact, and that is because of their different operations due to being a set of linear functions. For adding matrices, imagine it like adding linear functions row by row. So 4x plus y equals 1 and 2x plus 2y equals 0 added together equals 6x plus 3y equals 1. This holds true for the entire matrix, so that's why addition adds each element with its counterpart. Multiplying matrices is a more interesting endeavor, as it does not seem intuitive when just looking at matrices by themselves. But when looking towards matrices as linear functions, it starts to make more sense as to why multiplying matrices is performed in this way. Matrix multiplication is actually defined for convenience. It's used to represent linear transformations in a way that makes sense for mathematicians. It's more of a composition of linear functions instead of straight multiplication, with the column of the second matrix being composed with the first one. In simplest terms, when you multiply a matrix, you're actually composing each variable of a column into a row. So when you compose 2x plus y into x minus 2y, you take each element of x minus 2y and insert it into the x and y variables of the first function, which results in 2x minus 2y. So negative 2y is inserted into the y variable, and then x is inserted into the x variable, so you're left with the result 2x minus 2y. Now take this into a matrix, and imagine 2x plus y as a matrix 2, 1 with one row and two columns, and x minus 2y as a matrix 1, negative 2 with one column and two rows. And then you can see that the matrix multiplication intuitively works more like composition than straight multiplication. With this knowledge of matrix multiplication and addition in terms of linear addition and composition, you can now look towards elementary row operations. There are only 3 elementary row operations, but they're extremely important. I've provided them on this video, and they can be used to both find the solution to a set of linear equations and the inverse of a matrix. For the set of linear equations, you just have to put in a dotted line across the matrix with the coefficients of the linear equations on one side and the number solution on the other side. To solve for the linear equations, you must then only use those 3 elementary row operations to then make the left-hand side the identity matrix while still doing row operations on the right side. If done correctly, then put the coefficients on the variables again, and then you have your solution to the equation. For finding the inverse of the matrix, you start with the matrix you're finding the inverse of on the left-hand side and the identity matrix on the right-hand side. Then, with elementary row operations, you pull a switcheroo, and then you're left with the inverse of the matrix on the right side and the identity matrix on the left side. What you've basically done is, through elementary row operations, is you multiplied each side of the extended matrix by the inverse of the left matrix. So then you're left with the result, which has the inverse for you. This is a much more useful method of finding inverses than memorizing formulas, so I would recommend using it if at all possible. So that's my quick video on matrices. If you have any suggestions for future videos, please leave them in the comments or in Discord. Thanks for watching.